to invite all the speakers from this morning to come back up here, the award speakers, people speaking on behalf of awardees. I'd like to have you all come up here. And we will break for lunch early. Don't worry. We're way ahead of schedule here. But I would like to give the audience the opportunity to ask questions of these people. And do I see any hands? I know it's kind of hard to remember the talks when they were so long far ago. There's one. Okay. Great. Sandy? Come on up. Find have a seat if there's not enough seats. There you go. Great. Okay, we're not hearing the question. Ricky, can you do something about the microphone, or maybe hold it close to your mouth? But no, is it turned on?
I heard it, so I can repeat that.
Yeah, I know,
Hello,
but
can
I'm
you hear
worried
me?
about the cube not working for future. So Ricky's going to work on it. But go ahead and repeat the question.
Okay, so is this one working? Can you hear me? Hello? Hello?
Okay, I don't know.
All right,
We're having
I can
technical
stand up for
difficulties.
this one. So the question was regarding the pinhole effect for seeing the shape of the polygon of the moon's shadow projected onto the Earth. So really, it's if you imagine a sphere as the sun and a sphere as the moon, then it would be, a perfect sort of the moon would perfectly obscure the sun if we were at the appropriate distance all at once, and the effects of Bailey's beads would probably be eliminated. We might still get the diamond ring effect, which is that last or bright burst of sunlight that you can see before the sun is completely obscured by the disk of the moon, and the first thing that you could see when it emerges again after the total eclipse. But the moon is not a perfect sphere. So if you can imagine a giant circle light source and then putting a big circle in front of it and then sort of carving out some notches, which is essentially what impact cratering has done on the moon, then you get little dips that allow a little bit of extra sunlight to reach the ground, and that is what makes those pinholes. Those pinholes are those lowest points. I'm not sure I'm explaining it incredibly well. If someone else would like to, Noah, say something more.
A moon expert right next to you.
Maria, if you would like to say that, yes, that would be great.
She knows more about the topography of the moon than anybody
Yeah, that's
I know.
a very good point.
Is that one on?
Oh,
Yeah.
yeah. Can you hear me? Yeah. No. Just the irregularities in the topography just cause a refraction of the rays that form an irregular pattern. So I mean, these polygons are not regular; they're irregular.
Okay.
So.
Margaret?
To what extent do the Earth topographies interact with that?
Can
Well,
everybody hear that question?
Yeah, the question was, to what extent does the Earth topography interact with that? Let's see, probably somewhat, because it's a projection, okay, and it's you're kind of projecting onto a flat surface, but it's actually variable.
Okay. So whoever's got the
You
cube.
can see that effect if you watch the visualization. You can actually watch
how it
the
changes.
mountains. Yeah,
Yeah.
you can see how
Yeah.
draping in a regular shape over in a regular shape causes it to change throughout the extent across the country. So it's really neat to see, especially in the oblique view.
Okay,
Yeah,
Jim, speak.
well, I was just going to comment that I believe these projections, they're so accurate that it's nice working, that they in fact do take into account the local topography on the surface of the Earth when you calculate that shadow, is my understanding. So it really is pretty phenomenal.
Yeah.
Who do I throw this to?
Okay.
So I just want to say, Ernie did my opening image of Oriental.
Could you tell me Ernie's last name? I heard
Wright.
Ernie a lot.
Right,
Ernie
Wright.
W-R-I-G-H-T. Yeah.
Okay,
So
great.
he did the Oriental image that was the opening image in my talk also.
Thank you.
Yeah.
I have a couple of comments and then a question for Maria, but the comments are, we at Survey printed up quite a number of eclipse glasses, and we're going to make those available to everyone here for watching the partial phase. As I hope you all know, you can look at the total phase directly without eclipse glasses. So tomorrow morning, come up to the front and grab your pair, please. The other comment that I wanted to make is that I read a very nice op-ed by Ellen Stofan just the other day. It's actually from last year, where she talks about STEAM. And I didn't know this ahead of time, but she was actually an art history minor in college and has a long-standing interest in this. But it's really, really supports what you were saying earlier, Tracy. So, so I applaud that. And then, regarding my question, Maria, what I was wondering is, at what depth in the moon does the Grail stop being quite as useful, and then you're looking more at the data from the retroreflectors? And what do you see as a possibility for the future when we hopefully get even better retroreflectors up?
Okay, so the deal with Grail is that it went from crust to core. So we, we went all the way down to degree, 2, which is as low as you can go in gravity, except for 0, which is the point mass. And there is no 1, because 1 goes away because you define the center of mass of the planet to be the center of mass of the moon. So there is no 1 term. So Grail is sensitive down to the very longest length scales of the moon, which is the circumference. Okay. However, the addition of the reflector data with Grail improves the joint solution. Okay, and just to put to provide some clarity about just how powerful the addition of the surface data is. So of course we will do a better job of understanding the deep interior of the moon, which I didn't even talk about today because there was only a half hour. But these data also have incredible implications for everything up through tests of the strong equivalence principle and relativity, and what's really interesting is somebody's signal is somebody's noise, and so the Earth-Moon system is used as a test body for a number of things in fundamental physics, and so when you see a perturbation, you need to understand how much of that is coming from the fundamental physics and how much of that is coming from the moon itself. So the internal structure of the moon is actually one of the major error sources in advancing our understanding of fundamental physics. And actually, when we designed Grail, I'm not a general relativist, but I had taken general relativity, and I knew enough to hire a general relativist to come in and look at all the formulations that we had. Somebody look at it both at JPL and at the Goddard Space Flight Center and make sure that the software was all set up to account for all the terms in the physics, so that we could use that information. And so the the Grail data now is being used in that way, but certainly looking at the long-term perturbation, the problem was Grail was only there for 6 months doing its thing, and lunar retroreflectors are there for a long time. And so adding more reflectors on the moon to monitor the long-term perturbations it's going to be hugely important, both for understanding lunar structure and for fundamental physics as well.
Okay, great.
Sounds like we need a geophysical network back on the moon to me, but
Sort of does.
I may be biased on that one.
That was always a good idea. I like it. Okay, I have a question for, I have a question for the entire panel here. Everybody, I'd like you to think about the students in the room today, and I'm going to ask you to give the one piece of advice that you would give to them. And I know whichever side I start with, all the easy answers are going to get used up. So I'm giving you a few minutes here to think about what you would say to them. But I really want it to be more than just the pat answer. I mean, tell them what it is you wish you had known when you were maybe pick whatever stage you want, undergraduate, graduate school. What one piece of advice do you want these students to know today? And let me start with Marcello.
The advice is obviously to have a lot of passion in what you do, and to be aware that even in science, even in the exploration of the solar system, which is fascinating, nevertheless, there's a lot of boring stuff to do in everyday life. And so be careful and let your passion overtake that moment of boredness and keep going with determination.
Okay, so push through the boredom, all right? Maria.
Yeah, so my advice is don't be afraid to fail, okay? When I talked this morning about the Mars Observer mission, so, I mean, it was fantastic. We won this instrument to go to Mars, and I had just gotten out of grad school, and it was like, God, this is fantastic. And then it just went away, okay? 3 days from Mars, the spacecraft didn't get into orbit, and but you know, there was Plan B. There was Clementine, and actually the loss of Mars Observer, I still wish it wouldn't happened, but it was probably the best thing that ever happened to me, because it did make me unafraid to fail, and so, you know, as I went on, every time I looked at something, I would say, all right, well, you know, if I'm going to get upset about something, it's got to be worse than losing your spacecraft 3 days from Mars, because I recovered from that, and that turned out okay. And so it really gave me a whole new perspective on what it means to take a risk, to do something incredibly exciting and important.
So I have a very biased one that shows where I got to my career path, but I started out as a research scientist as well. And when I was having trouble, you know, analyzing data and writing up papers, I would go and talk about my research with kids. And that always reinvigorated me. And I thought the best part of my job as a scientist was sharing my excitement for the science. And I ended up making a career of it. So now I'm no longer doing research. I just get to spend my whole day talking about how awesome the research of other scientists is. But I know a lot of scientists I work with say they are also reinvigorated and re-energized and remind themselves how incredible the work is that they do and how exciting it is when they share it with others at an outreach event, at an education event. So students, I encourage you to get involved early and keep that energy alive. And if you need a little push again, I encourage you to talk about what you do and remind yourself how great it is.
That's good. Okay, Sam.
Well, I'm going to I guess my biggest piece of advice is something I learned from my good friend Joe Boyce. And Joe has much wisdom, for those of you who know Joe. And he once told me that it's always the meeting you don't go to where the dumbest decision gets made. And so I would say always go to meetings. They are fun and useful because you really do need to be in the room to make sure that the correct decision gets made.
Good. That's good. Okay, great. Tracy.
My advice would be that there are a lot of amazing people here and in the community as well. And so if you're ever interacting with someone, if you're in a role where your advisor or someone else isn't meant to be for whatever reason, that there are other allies, there are other people you can seek out for, either to change mentors or at least to have an additional mentor that will help you do whatever it is, whether maybe it's not just directly science, maybe it's on a more personal level, but there's lots of people in the community who want to help, who are willing to help, and can serve as allies if you're ever in need of that kind of allyship.
Great, thank you. Addie?
So I got to go back to see the students who were at Loon GradCon yesterday. Was it yesterday? It seems like so long ago already. And the advice I gave to them was use this opportunity specifically, but opportunities like this in general to get to know not only their colleagues and their peers, but also everybody else here in this room. And I told them that if they went up to anyone in this room would be happy to talk to them. So you all heard that now. But seriously, I think that just going up and talking to people, introducing yourself and asking what they're interested in, you'll find that you have amazing commonalities, except maybe with Clive. And that you'll be excited about who you meet and what you can do from there.
I got nothing. So, what I've heard, down the line here is pretty much what I was going to say. Number one, don't be bashful. If you want to find out to get involved, if you're bashful, you're not going to get involved. So you need to come up and speak to people, ask questions. So I tell my students back at Notre Dame, there are no dumb questions in the beginning, but you got a question, you got to ask it. So I mean, that's just the way it is. And the other thing is if you do what you love, you never work a day in your life. So my wife asked me about 3 months ago. She says, "When are you going to retire?" And I said, "When I start working."
Good. Well, that was excellent advice from everybody. Thank you so much. I really appreciate it. And now I've given you all time to think of questions. Do I have any more questions in the audience?
Yeah, I have
Yes.
a quick. Oh,
I'm sorry.
sorry. Andrea, I saw on one of your slides about the locations for INOM, and you said 49 states. Which one state is missing, and how can we rectify that? Maybe there's somebody in the room
I
that wants
actually
to do that.
should look that up again. But over the years, we have had every state, but this one dropped off. So I'll have to track who that is, and I will get back to all of you so you can all flock to that state.
Eagle eye, Brad, caught that. Okay. Jack Schmidt, what is your question?
Clive, you didn't mention something that Larry Taylor has been very active in, and that's the study of diamonds and their inclusions. Do you have some further comments on that?
If we open up that whole can of worms, I mean, I tried to focus on the planetary side, but Earth is a planet. Sometimes we forget that, especially the Flat Earth Society. But that's but he has done monumental work in mantle petrology and diamonds. And in fact, when he brought me to America, sight unseen, it was to do mantle work, and this lunar stuff was a sideline. So I worked on mantle petrology with him as well. We have a few papers together, and he has continued that work, especially in the state of the Russian diamonds. And he has quite the operation at UT Knoxville with regards to being able to look at these diamonds and especially the inclusions within them, because they are little tape recorders of what goes on way deep interior of our planet. And he spent a lot of his time working on that as well. But I kept it to the lunar side. If I'd have opened that up, we'd have been way over schedule now. So, and I want to emphasize one thing I didn't really emphasize during my little homage. But Larry is exceedingly humbled by this award, and he wants to thank everybody here and who isn't here, even those that have kept their phone on ring. But that's fine. That's fine. I'll wait for you to answer it, then I'll continue. So, still going. All right. Anyway, he wanted to say thank you very much. He's exceedingly humbled, and his work will live on, as will Larry, because he's a cat with 23 lives right now. So, those of you that know him, I don't have time to go into each one of those, but anyway, his work is both on this planet and elsewhere.
Oh, I see some more hands out there. Okay, Bill Botke. Could you bring the cube over to this side?
Got a question at the back.
Okay. Well, we've got Bill first, and then I saw another hand somewhere in there.
This,
Okay.
oh, here we go. Okay. Doing
Go
a
ahead.
cube. This is just a comment about Sam's talk about Wendell Mendel, and you mentioned. I just want to point out to the audience that if you ever give public talks and you wonder, am I doing any good at all? I also, as an undergraduate, remember seeing Wendell Mendel give a talk at the University of Minnesota and thinking it was probably the coolest talk I saw as an undergrad. And I was already, probably inclined to do this, but it really made a difference. And so these talks do matter. And so I wanted to get your comments on that. But it's amazing that we were both thought his talk was such an inspiring thing because we both remember it.
Well, I think it speaks to the importance of. I think it speaks to the importance of engaging the community because we really do have the best jobs in the world. We really do. We're pioneering frontiers. We're pushing back the boundaries of human knowledge. This is fun. It doesn't get any better than this. And I think, unfortunately, that enthusiasm doesn't always get conveyed. And the importance, because we all work for the American people one way or the other. And I think the importance to the taxpayers who fund us to do these amazing things needs to be very clearly communicated. And Wendell is great. He still has that enthusiasm. He still has that infectious desire to explore, and so. But it wasn't a talk. It was a really good magazine article, and I guess, and I've got a digital copy, and I guess the thing about that article is that if you, this is kind of sad, but it's also kind of valid in a way, is that you could cross out the date and put 2017, and many of those statements in that article would unfortunately still be valid today. So I think we all kind of need to do a somewhat better job of actually finishing at some point.
Okay, there was a talk in the back, and could you bring the cube to it? I'm not sure who it was. Oh, there's already a microphone. Never mind. Go ahead.
It got mentioned earlier. I forget who said it, but pointed out the number of younger folks in the crowd. I think that's a huge success of NASA's. So I have a two-pronged question for the panelists. To what do you attribute that success? And for those of us being the next generation, what can we do to continue that success of bringing in new people into the fold?
I'll start with an answer to that. So a large factor in that success is Yvonne and her team here at Survey, who have really, really worked hard to support the next generation of scientists. So they have funded Next Gen Scientist Group. They've funded Loon GradCon since its inception. And they've done an amazing job of bringing people here and making sure that young scientists get talks this week, for instance, and things like that. Noah Petro in the back has been a key member in helping the Next Gen scientists as they've come along. Sarah Noble, I know Jake's in here somewhere. They were in the original group that sort of helped establish this idea of we need a new generation and better ways to pass on the science and get people more involved again in lunar science. And the fact that you asked that question means you're interested in being involved. So I would recommend you get involved. What's your name?
David Bird.
David. All right. So David Bird. Bert. Okay. David Burt is interested in being involved in Loon GradCon next year, or or the Next Gen Lunar Scientists. There are Facebook groups, and there are things like Loon GradCon, and at every conference, there's usually a meeting for younger or early career scientists. So just keep your eyes out for that, and get involved as much as you can. And that's what will help it continue to move into the next generation.
Okay,
Can I
thank
comment
you.
on that?
Yes, please.
Oh, it's still on. All right. David, yes, and everybody else here. Communication is important, and I run a lunar listserv. Some of you may be on it, and occasionally there are some interesting conversations that go on there. But if you want to be part of that, just let me know. Come up and talk to me, and I'll give me your email address, and I'll get you added to that. But communication is important, and also just want to point out that Survey, and as Sam mentioned, that Survey sponsors the B. Ray Hawk travel grants for the Next Gen people to come to the League meeting. At the town hall, I will say, and I'll say it now, the League meeting's 10th to the 12th of October this year in Columbia, Maryland, and more details are on the web. And at the Lee Town Hall, it'll happen tomorrow.
That's great. And you also remind me that, you know, for the people who have posters, we have a poster competition, and first prize is winning $1,500 this year in travel money. So that the way that works is the person will contact us and throughout the next year, and any conference that you go to except this one, we cannot pay you to come to this one. We will be able to reimburse you up to the amount of the award that you win for that poster. So several of you are going to be judges. These are for students, I should have said, okay, sorry. We're just talking students. So for students, some of you will be asked to be judges in the next day or two. Please take that job very seriously. This matters a lot to these students. Any other? Okay.
Can I? Sure. So I just wanted to take this opportunity to tell an Angioletta Corradini story, one of my favorites, so of many favorite stories that I have about Angioletta. So there was a scandal in Italy, and the prime minister appointed his consort as science minister, and she didn't have any background in science, and so there was outrage. But Angioletta, instead of being expressing outrage as just a protest, she got together with a group of Italian women scientists, and they decided to hold a conference, and they called it Women and Space. And she went to Aerospatiale, the Italian space agency, and she got them to underwrite it. And they invited top women space scientists from all over the world, and some from within Italy, and they held a day-long conference in Rome, and they held it in the institute where Galileo took his first observations of the moon, and they invited the press, and people from all over Italy came, men and women, to this conference. So because of the quality of the speakers that they invited, and so it was just her way of doing something just amazingly positive to offset something that was very negative. And I think that that's just one of her many qualities, and I just wanted to share that with you. So.
Well, thank you very much for this beautiful memory. And the message that comes from Angioletta is that, science doesn't find you. Sometimes jobs find you, or sometimes you work for money, or sometimes you work simply because you need to. But if you want to work in science, it's just because you do it for love, and only for love. And that's the overriding motivation.
Thank you. Those are very touching stories. So Jack has the last word, and then we're...
One question. With respect to the eclipse, and waving at the moon, has anybody calculated how many cell phone flashlights would have to be on for LRO to pick it up?
I think that's a necessary calculation. We'll get on that.
All right, I hope you will.
Okay, and with that, we have one more, okay.
I wanted to thank Addie for bringing up issues of inclusion and equity at the end of her talk. I think that's a really important conversation to have, because at the end of the day, exploration science, science in general, it's done by humans. We're people. We have our biases. We bring a lot to the table, and the more different people with different perspectives we can bring into the community and welcome into the community, it benefits everyone in the community. So I would really like to echo Addie's call to think about what we can do to welcome people into this community and what we can do to make this community the best it can be. So I really wanted to thank Addie for bringing that up. Addie, I've known you for about 10 years now, and you just get more awesome every day. So thank you so much.
Okay, thank you. Do you want to
respond?
Sandy? Thank you for that. Okay, so this has been a great conversation. We are ending this session early. It means you're going to have a longer lunch because we're still going to start at 1:45 as listed. Oh, wait, we have news? Oh, I'm so sorry. Don't go anywhere. We're doing lightning rounds. That's what happens when you don't have the program. Okay, I keep leaving it at the table. Brad Bailey, would you please come up now, and we are going to do the lightning rounds, but let's thank our panelists here. Thank you so much.